for here.
Let's go for it. So, the idea here is to tell you some stories about projects in which we have applied the mixed model line design, mixed model material flow methodologies to very short projects. So what we're going to tell you are Kaizen stories, Kaizen projects that were remarkably impactful. And Richard and I are going to be taking turns and tell you some of these stories. And most of these, all of these, were 1 week projects. I do not recall any of these taking any longer than 1 week. So as we go through them, we'll tell you if we can remember how long they took, but they all were, short projects. Start on a Monday, finish on a Friday with a presentation. So, what do you say we go, Richard?
Yeah. So just our creds here in terms of why we're qualified to be talking about these things. Gerard and I started working for the same lean consulting company the same year, right? Not the same month, but the same year, 1994. So we passed our 30-year anniversary. So we've been doing this. I could have put 31 years in there. And so clearly over that time, worked with lots of companies, big ones and smaller ones. So we have a kind of a rich pool of case histories to draw from for this presentation. And Gerard and I decided when we started working together as a separate company back in the early 2000s that we needed to decide what our specialty was going to be, right? So we could attempt at least to be the best in the world at what we do. And the handle for that, or the phrase we're using for that, the slogan is mixed model manufacturing. And so what we mean by that is the ability to produce different models. And this is not rare. I mean, this is a very common thing, but to be able to produce different models or different variants of the same product on the same line and not lose efficiency, not lose throughput or quality, and be able to do that well. And that's our wheelhouse, so to speak. And, lean is a big, huge topic, and there are a lot of areas that we could have chosen, or we could have tried to be the best at everything, but this is really where we've focused. And so I think that we've been successful at that over the years, and our clients, I think, will agree with this. So we're going to share with you in this webinar some of the examples that hopefully you can apply, or at least get inspired, get enthusiastic about how change is possible, and how things can be done in a relatively short period of time. Now, we do have these two Japanese words. We're not big fans of using a lot of Japanese words in our practice, but there are two that we use. Kaizen is one that everyone knows. And then we have this other word that maybe you're less familiar with called kaikaku. And what we're referring to here with kaikaku is big change. And that's really kind of where we focused. In other words, when we talk about line design, that's probably not a Kaizen event. It's a bigger effort where we take an entire assembly line or entire product line and we redesign the workflow or the value stream, if you want to use that term. That's more like what we'd call a kaikaku. Kaizen's different. Kaizen would be either an individual improvement. I mean, there's a what's called quick and easy Kaizen, where an individual worker would look at the work they're doing and come up with ways to do it more easily or better, quicker. Or more typically a Kaizen event, which would be, 2, 3, 4, 5 day kind of focused effort to improve a process. So in this webinar, we're talking about that, as Gerard just mentioned, a Kaizen event kind of format where you can make these changes relatively quickly. Anything you want to add to that, Gerard?
Yeah, the majority of the work we do nowadays is long-term project, medium-term projects where we take a line and redesign it. But every now and again, for proof of concept, we do a small line redesign as sort of a Kaizen event. In a week, we take a small line and we show the proof of concept. We don't do that much anymore because, as Richard said a few years ago, we said, we don't want to be the lean guys. We don't want to be the all of that. We want to be these guys, and these guys, we are the mixed model manufacturing guys. So we focus to be the best in the world at mixed model manufacturing and mixed model material flow. That is who we are. That is what we teach, and that is what we teach in partnership with Toyota, as a matter of fact. So that is what we do today. As a matter of fact, most of the projects most of the Kaizens we're going to tell you about, they are not from this year. They are part of our history, but the application of the methodology that we use goes directly to these, and we encourage our clients to apply the methodology. We just tell them, hey, do it without consulting help. Now, every now and again, they ask us, hey, help us out. And we do. As we like to do it sometimes, as we like to say sometimes, there are certain things we do in the lean arena for friends and family, for clients, old clients that have been with us for a long time. We have clients with whom we have been since the 90s. So yes, they ask us, hey, can you help us out with a specific lean related project like quick changeover? And we're not going to say no to a long-term client.
So there was a study that was done, documented in the book Toyota Kata, and the question that was asked was, where are the benefits of lean manufacturing coming from primarily? And so they actually analyzed the Toyota company. This was a study done in Japan, and the determination was that 90% of the bottom line benefits,
money-wise,
the hard dollar benefits came from Kaikaku, not from Kaizen. And 10% came from Kaizen. But if you talk to the Toyota folks, they don't denigrate the importance of Kaizen. But it's not so much to get big dollar improvements. It's to really sustain the lean culture and encourage people, develop their workforce, develop their people, and also to sustain changes that maybe were made in a Kaikaku kind of format. But the slogan is, if you're not continually improving something, then it's getting worse. Yeah. And so Kaizen is your way of putting the blocks under the wheel of the car to keep it from rolling back downhill, right? So Kaikaku is pushing the car uphill, and Kaizen is keeping it from going backwards.
And they will tell you very directly, Kaizen for them is for engagement and culture development, primarily. Now, do they every now and again find a diamond in that bucket? Absolutely they do, but they don't do it for that. They don't do it for the money. They do it for engagement and culture development. So with that.
Beautiful. Yeah, so let's get into it. We have an assortment of different projects that Gerard and I brainstormed, came up with. We even have one or maybe two hospital examples, so not just manufacturing. But we're going to go through them and take turns and talk about them in a succinct kind of way. So a variety of different strategies that were used, but they were all done fairly quickly. I can't say that they were all done in a few days, but they're all fairly easy to do. And of course, every Kaizen event requires follow-up, right? So it's not something that's done in a week and you never have to look at it again. Requires sustaining. So let's get going. Let's see. And we photo coded these. So this one's mine. Case one, touch for quality. Now, touch for quality is something that's actually extremely easy to do. I'll explain how it works briefly. But I can't think of too many things that could have as greater impact for such a low cost and really low effort. So it's a real simple concept. When you're working in a workflow, say an assembly line, and a part comes to your station, before you begin your work as defined in a standard work definition, what you need to do is make sure that any quality critical points that could have been done wrong at the previous station, you check those first. So it's a quick inspection, not of your work, but of the work that was done previously. And then you do your work, that's standard work, you do that. And then before you release that unit to go down to the next station downstream, you want to double check your own work. Not everything, but those quality critical points that could have been done wrong. So that's the simple, very simple idea. Now, how do we get that to happen? Well, we suggest you embed that, you incorporate that practice into your standard work definition. You don't make it optional. It's included in the standard work, and the time that it takes to do that is also included. So you could be adding some time, but usually not a lot. It doesn't take a lot of time.
It is marginal.
Yeah. And I was really pleased. We got some videos from a long-term client of ours just recently, in the last few weeks. And I was looking at the video, and I said, what is this guy doing at a station? And I realized, oh, that's great. I'm so pleased. He's doing touch for quality. And I said, okay, they took that to heart, and they included it in part of the standard work, right? So check the work coming to you, check afterwards. And the benefit of that is, depending on how variable your work is, how high the risk is for workmanship errors, it can virtually eliminate or greatly reduce workmanship errors just through that simple practice. Just pay attention to what you're doing and check your work and check the work coming to you. So not rocket science exactly, but many organizations don't do it, right? You do the work and move it on, right? And
why the touch? Why the touch? Notice that in the picture that person is holding something, holding a stick, holding a pen. Why the touch? Try it. You cannot help it. If you touch something with that stick, you cannot help it but to follow the stick, to follow the pen with your eyes. So if you go and touch, you have to look at whatever you're touching. So you're accomplishing two things. First of all, your brain switches. You go from doing to inspecting to looking. And secondly, you go and you look. So you switch, you slow down, you look. Yes, you slow down. You're no longer in autopilot. And in those few seconds, you became an inspector. You switch hats, and then you take your hat back off and you continue working. You put your inspector hat back on. When you take that pen, that stick off your pocket, touch again and let it go. And again, this doesn't double your time. This may increase it by 1%, 2%. We're talking seconds. Because you're inspecting everything. You're inspecting 2 or 3 critical points that if you let them go, they become defects that will be difficult or expensive to fix. So if you're not doing touch for quality, you're leaving money on the table for, I'm going to say, for free.
Yep. Okay, so I think we've covered that.
Yep.
And I have an actual example of this later on in this webinar, an actual case history, where we applied this. How long should it take to do this? It depends, but not that long, right? You just have to identify those risk areas,
Yep.
kind of like an FMEA, right? Failure mode and effect analysis. Where are those risk points, and make sure they get checked.
I myself designed one of the first home affordable at that time, 1996, home theater systems, mass production home theater systems. There were defect problems with the transducer of the subwoofer. We went to lunch at a Chinese restaurant. And I'm a little ashamed to say that I stole a bunch of chopsticks, came back, gave it to the workers, and within 2 days, the defects on the subwoofers went down by 75%. 2 days, 75%. Why? They slowed down, they touched, and they found that the transducer, instead of going over, was going under. So they took the time to stick their finger under and put it over. 75% in 2 days. Thanks to the stick.
Okay. Case 2, quick
Oh,
changeover in machining.
this one of our beloved clients in Wichita, Kansas, where we've done a lot of work because at one point in time, Richard, we were the suppliers of mixed mold manufacturing for the aerospace industry, for the tier 2, tier 3. And these folks did a lot of work for all their work for the aerospace industry. And in this particular one, they wanted to take a low risk approach and not touch their 5-axis machines, just went to the 3-axis department and do a quick changeover project there. It was a 1-week quick changeover project, around 4.5 to 5 hour changeover average there. And again, in observing, what we found out is that the great majority of the changeover is wasted on preparation. Richard used to use a term that I started using at the time, that the most important part, he didn't use the word preparation, he used the word choreographing. So I started using the term choreographing. Is choreographing the changeover, right? So in preparing for the changeover, and basically what we did was, in preparing the changeover for the next job, we reduced it to 1.5 hours, and for the second job, we reduced it to half an hour. It was, and again, this happened within 1 week. And basically what we did was we applied the tools that are described in one of our books, one of the books Richard and I wrote. We just wrote it for the hospital business, but we applied exactly the same tools. And again, and basically we followed the process, the mental process that we follow in mixed mold line design. And again, here, just went from 4.5 hours down to 30 minutes. And the 30-minute number kind of stuck in our head because we started using that number in later projects for hospitals. And that became our standard for changeover in operating rooms. We said operating room, 30-minute changeover, 30-minute changeover, 30-minute changeover. And of course, if we could do better, we would do better. But we were always very careful. In the operating room, we didn't want to go shorter than 30 minutes out of concern for infection control. We'll get to that in a minute. So the 30-minute mark became very important. Again, quick changeover, 1 week, and that is something that, again, we invite you to get a copy of our book. It's a very quick read. It is written for hospitals, but I'd be shocked if one of these projects were to take you any longer than a week. You've done a few of these too, right, Richard?
Yeah, I was going to say, in hospitals, you can imagine when we talk about $1 million savings, I hope you didn't think that title was too over the top.
Oh, no.
But in hospitals, you can imagine the cost or the value of an operating suite. And if you can fit in an extra procedure because you've reduced the changeover time in the hospital, that's a big deal.
Yeah.
One hospital I worked with in I think it was Baltimore, they had 18 surgical suites in this hospital. So it's not just one suite, it's multiplied by 18. So if they could fit in one more procedure, assuming they had the demand for that, then that's huge. I mean, that's a tremendous revenue impact, positive for the hospital. So,
one of our clients, 44 ORs. and the waiting list was months. So getting all those procedures in, and we were able to get 2 procedures per room extra by reducing changeover, because this hospital had a lot. We'll get to hospitals.
Okay, very good. So this is on this case too. This is basically SMED, right? And you can do a SMED project in a week. That's pretty much clear. All right, next one. This is an interesting one. This is whip control. This is one I worked on. This was in California, aerospace company. And basically, the challenge they had is kind of unique. They were doing remanufacturing. And the product was a landing gear. So it came in on a big pallet, big for a, passenger airplane. So pretty big unit. Every so often you have to rebuild these things, right? A certain number of landings per FAA regulations. So the trick though is it comes in the door, they have to take it apart, they disassemble it, and they kind of determine what needs to happen for each piece. Some parts get thrown out and you just use a new one. Some use as is, just clean it up and you can reuse it. Some have to get remachined, et cetera, repainted, et cetera, et cetera. But the thing that was unique was those same parts had to come back together. The major components needed to come back together into the same unit. So you needed to track the same parts, serialize and reassemble them after they've gone their various routes, throughout the factory and come back together in final assembly. So Little's law basically says the more stuff you have floating around in process, the longer it's going to take to get anything finished. And so this particular project was trying to apply something called Polka, by a guy named Rajan Suri called Quick.
Yeah, big shout out to Dr. Rajan Suri. And this is to show you when we talk about public intellectuals, we don't not only talk about us. Yeah. Big shout out to Dr. Rajan Suri, because what I love about this project is what I love about this job is the fact that every now and again we look at something and we go, I don't know about this. I better learn. And Polka was something we learned, and it was actually quite interesting. Because when you look at flow manufacturing, we're not looking so much at a network, right? And Polka gave us the solution for the network with all the nodes, all the different nodes in the system, and Polka gave us the solution.
Yeah, the book, by the way, is called Quick Response Manufacturing. Yeah. If you want to look that up, by Rajan Suri. So anyway, the basic philosophy, I'll just summarize it for you in a sentence or two. The basic philosophy is to apply Little's law. We're not going to achieve single piece flow in a job shop kind of environment necessarily, but we need some methodology to reduce the WIP, right? To control WIP to a lower level in order to improve throughput time, the lead time through the factory. That's the basic philosophy. And it's achieved through basically a manual system. It's a series of cards. And so the philosophy is, unless you have a card that authorizes you to go to the next station within that particular work sequence, then you're stuck, and you have to find a unit that does have a card so you can keep things moving forward, but not overload any individual resource within that. So applicable to job shop type environments, which is what we had here in manufacturing.
Yeah. So, and we've done reman before. I designed reman lines, for example, for hearing aids, and it wasn't the same. It just was not the same, because I could get the hearing aids in one straight line. I didn't have this problem. This was much more complex. And without Polka, which, by the way, I also love the name Polka, pair of overlapping cards with authorization, right? Without Polka, without that, give me, here you go, then WIP gets out of control. and then there is this big piles of inventory here and famine over here. It gets out of control and machine utilization is terrible. And then at the end, that product that needs all these different parts, that landing gear that needs all these different parts, some of which were good, some of which are new, you need to go get them from inventory, some of which need to be remanufactured, never make it on time. Another great thing that Richard did for his team did for this project, again, just common sense, was to put together a shadow board for each job. So when the shadow board is complete, push it, assemble it, deliver it back.
Okay, so this is a big subject, Polka, but I encourage you to find out more about it. And we're not the only ones that have applied this. I mean, I think we were inspired to try it in this environment because I was talking to some folks from John Deere at a workshop, actually, and they mentioned Polka, and I said, "Polka, are you guys doing that?" "Oh yeah." "Well, does it actually work?" I wasn't sure, and they said, "Absolutely, it does work." I said, "Okay, we may have an opportunity here."
Yeah.
All right, next one. Saving a plant. That's a big one.
This one, 100% mixed mold manufacturing. Long-term client, multiple plants in multiple different states. And one of the plants was in a state with very heavy union influence. And they wanted to close the plant. And they asked me, "Gerard, could you help us close the plant?" And I said, "We don't do that. We don't like doing that. We don't do that. We've done it a couple of times. But for, again, friends and family, just don't like doing that. Don't call us for that. We don't want to do that. We are not interested." But these folks have been with us for 5 years. He said, "Gerard, please help us out." I said, "Why do you want to close it?" They told us productivity is terrible. Worker attitude is terrible. We keep losing money. I said, "But I've never been to that place. And you're asking me to go and help you close it. Why don't you let me go and take a look at it and see if it can be saved?" So, "Well, go take a look at it." So I went, missed my flight, arrived there, 5 a.m, just went to the hotel, took a shower, went straight to the plant. And at the lobby, the president of the union was waiting for me. So I show up, he looks at me and says, "You're Gerard?" I said, "Yeah, I'm Gerard. I know what you're here to do." I said, "What am I here to do?" He said, "You're here to make us lose all our jobs." I said, "No. I'm here to take a look at I'm going to tell you what I'm here to do. I'm here to see if this place can be saved." He said, "Seriously?" "Yep, seriously." He said, "You tell me," he told me, "you tell me what I need to do to save the jobs of my brothers and sisters, and I'll do it." I said, "Yeah, let's go have a look." As we're walking out, I said, "What is the worst line, the worst department with the worst attitude and the worst productivity?" He said, "Oh, easy." Took me to the back of the plant, a department that built a connector box. And that connector box, basically a sheet metal box with a connector inside made of basically a plastic base with copper guts. He shows me how it's made. It was a bunch of middle-aged ladies that were standing at presses, and on the side of on each side of the press, they had a gaylord or a contico, and they had to bend over into this contico, take a part, put it on the press, apply work, bend over, put it back on the other side. Around 732, if memory serves me well, times a day. And I look at that and I go, well, no wonder these people have a terrible attitude. Their back must hurt like hell. And they say, yeah, Huh. I said, this is the one we're fixing. He said, what do you need? Well, we don't have a lot of time, brother. So this is what we're going to do. I'm going to, finish things up here. I'm coming back on Friday, Saturday, Sunday, we're teaching class. Monday, we are redesigning this line. So that's what we did. We did this really quickly. And I said, you need to find me a place where to do a pilot line. He himself, with the plant manager, the materials manager, cleared the space in the warehouse. We set up a pilot line. After we redesigned, we taught the class on Sunday. We stayed late. It was Saturday, Sunday, which, by the way, was a 3-day class. We stayed late both days to teach it. And Monday, we did the line design. Tuesday, we finished the line design and trained the people. Wednesday, we set up the line in the warehouse. And the ladies felt very self-conscious that all the guy workers were gawking at them. So we put tarps around that area. And by Thursday, they had doubled their production. And they were walking around with their backs not hurting. We took their productivity numbers back to the CEO who sent me there. And I said, what do you think? He said, can you do that with every line? I said, absolutely I can. And the plant manager and the president of the union were there with me. I look at them and say, guys, can we do this? Absolutely we can. Yep, we can do that with every line. He said, plant remains open. So the plant remained open in 1 week. Well, it was 1 week and a couple of days. The plant was saved and remained open. And it was all because, first, mixed mold line design and the attitude of the people there, including the president of the union, who said, what do I need to do? And he was there with me designing the line. So the proof was in the pudding. The plant stayed open.
All right. Congratulations, Gerard.
Yeah.
Yeah, we have several examples of that where the plant was at risk of being closed and, it was saved.
There was a certain corporation in upstate New York that before we showed up, they wouldn't just close plants, close and bulldoze them.
Bulldoze them.
Oh, yeah.
That's pretty extreme.
And we saved a couple of them.
Yeah. I remember one that I worked on in North Carolina. The issue was, I don't know why people do this. I think the philosophy was, let's keep these machines running because we're earning hours or something like that. And so
build inventory.
We walked into this warehouse, the inventory was to the roof. I mean, literally, these were high ceilings too.
Oh, yeah.
And so lead time was horrible. Inventory, work in process or raw materials as well was just out of control. And this plant was a target. And so it wasn't that difficult actually to help that. You just had to get out of that mindset of, unless the machine is producing stuff we don't need, then we're losing money. No.
David, how did we avoid bending into the Gaylords? Because the line, instead of going in and out, in and out, in and out, we pull the unit from the Gaylord at the beginning and run it through a conveyor, and it went from press to press to press to press down into the Gaylord at the end. The ladies didn't have to go in and out, in and out, in and out. It went through all the different presses, and these were Denison presses. And all the parts, which they were not that many, 4 or 5 parts per press. They were presented right behind the press. They were just within arm's reach. Hopefully that answers your question.
Yep. Okay.
Time slicing. I love this one.
Yeah.
By the way, 10:37, Richard. Time check.
Yeah, I'm watching the time here, so we'll maybe speed it up a little bit. This one, it was a situation where it was in the accounting department. So this is lean in the office. That's a great example of this as well. The issue here was that these units the company was selling were quite expensive. For the customers, about a $300,000 invoice that they would send out, per unit. But it was taking them between 5 and 8 days to get an invoice out once the unit was finished, right? The unit was completed, but they had a delay of a week or more to get that invoice to the customer, which of course delayed their payment by that amount of time as well. The customer doesn't care when you finished it in your factory. They start the clock when they get the bill, right? Get the invoice. So the issue though here is that we wanted to set up some kind of flow or some kind of multi-departmental workflow, but it wasn't a full day's job, so it wasn't going to be a permanent situation. So working with the 3 departments that needed to work together to get the invoice done, it was customer service, it was engineering, and it was accounting, those 3 groups. And the total work required to actually get this done was not a lot. It was like 45 minutes, something like that, of actual work time to get it done. But it was taking 5 to 8 days. Now, why was it taking so long? Because these people were not even in the same buildings. And so when one group, one department would finish their work, it would go into the intercompany mail and then get delivered over to the next department, the next day, if you're lucky. And then it goes into the in basket over on the next department, doesn't get opened and worked on immediately. So that's what we were confronting. So the agreement among those 3 departments was, look, we're going to set up a work area with a workspace. It didn't require a lot of space, but we're going to have you 3 departments sit down physically together on a regular schedule. It may not even be needed every day, but when it's needed, you're going to sit down together and you're going to complete these invoices as a team in real time and get it done. And then you can go back to your regular job. So that kind of workflow is variable, but when this work needed to get done, we did not want to put it into the intercompany, interoffice mail. We wanted to do it together as a team. And so that became the new practice. They had a schedule, so people, they weren't called, at random. They had a regular schedule where they were expected to show up and work in this other area, this shared workspace. And then when the work was done, they would go back to their regular assignments. And we called that time slicing. So we're taking a slice of each person's time and putting it together in the same physical area to actually be able to physically create a flow. And so how long did it take to get an invoice out the door? A day or less, with this new way of working. So again, very easy to do, but in terms of cash flow, big improvement in terms of getting paid sooner, because it was a lot of money that was being left on the table. Okay?
Yeah. And what you do for this, and again, you calculate number of resources, and for that, again, number of resources equals standard time divided by TACT. The trick here is that instead of calculating TACT using an entire day, because if you use the entire day, the number of resources is going to be fractional. What you say is, what is my slice of time? And you say every day or every other day, this group is going to get together for 2 hours. That is how you calculate TACT. You basically fake a TACT time, and once a day, for the sake of discussion, people get together in a line of 3 for 1 hour, like the line I just talked about before. They take their stack of invoices, and they go station 1, station 2, station 3 out. And these, by the way, they were done on paper.
Yeah.
Yeah.
Okay, super. Let's move on. Hospital admissions.
I like telling this story because this one is pre-electronic health records. And I insisted on doing this one pre-electronic health records because once you get the implementation of electronic health records or the implementation of ERP to come over, they don't want to do any improvements. They will take the process, whichever way it is, and put it in because they don't want to take any responsibility for the improvement or the failure of that improvement. And you know that always there will be some mishap. They don't want to take any responsibility. And we asked, hey, how long does it take to do an admission? Bedside, they tell me it takes 2 hours if you want to do it right. I'm thinking 2 hours of a nurse? That's a lot of time. Well, no, we can do it in 90 minutes if we don't do it right. We want it done right. There was a trick there in observing an admission. It's uncomfortable for a consultant to be observing admission, especially when someone is in pain. It's just not okay, right? So the observations were tricky. So we had clinicians observe and report back to us. And what we realized is that many of the questions were just irrelevant, right? Not only irrelevant, they were going through a script that, and then I experienced some of that myself at another place. I am a man of a certain age, and I had to go through one of those procedures that the man of a certain age needs to go. So I'm laying in bed, and they're asking me ridiculous questions. My wife is getting upset, and I go, no. Let them ask. I'm working here. I'm learning. They're reading, right? And they're asking me, do you have tattooed eyeliner? And I go, what? Why are you asking me that? Right? So basically, we took all the paper, and that was the nice thing, all the paper, and we streamlined the paper admission, and we said, guys, what would be reasonable? Well, it would be great if we could cut the 90 minutes down to 45, and we said, Richard and I were on this project, 30 is the goal, 30 is the goal. The first admission was done in 28 minutes. And we said, okay, 28, too good. Let's do it again, 28 minutes. Oh, really? Let's do it again, 28 minutes. Come on, guys, 28 minutes. 28 minutes was the magic number. And it was 28, 29, 28, 29. So, okay, it's under 30. And at that time, I don't know if you remember, Richard, at that time, we were having the local talent record the training session for these projects with local talent. And we had this nurse who participated in the project with this awesome Brooklyn accent who did the training session. And I remember we recorded it, and we did the PowerPoint presentation, and then we distributed to everybody. It was because normally we do. Richard has that DJ voice, so we were doing. We were using Richard as the voice talent, but this time we decided to use this nurse, and it was awesome. 28 minutes from there. That was then put into their EHR. The EHR was epic, and 28 to 30 minutes, that was the standard, and it was awesome. And frankly, you know what I if I had to characterize the tool we use for that, I call it 5S. We 5S'd the admissions process.
Excellent. And we always like to say that this time that we free up, what happens to that time? Well, it's time given back to the nurses to do what they really are hired to do, which is take care of their patients and not sit in front of a computer or not deal with paperwork.
Absolutely. By the way, one thing I need to say about that, when we presented this to management, the CFO said, I don't want to hear anything about financial savings on this, because the only way to save financial savings on this is to fire nurses. And what I want from this is to invest all this time in taking better care of the patients. And I'm looking at the CFO and going, damn, you're my kind of guy. So anyway.
Okay. This is a quick one. I'm still looking at the clock here, but this was an easy one. This was a company making blood glucose monitors, little handheld stuff you can buy. And I don't know what their formula, if they had one, was, but they had a huge amount of finished goods of these units. And so basically we took a look at it and we said, well, what if we put in place a finished goods Kanban? In other words, we're going to look at demand, what are shipments going out? We're going to look at production. We're going to do some analysis. We're not just going to make up numbers, but we can put in place a finished goods Kanban that essentially would, based on sales, based on these units going out the door, cards would be returned then to production and drive a replenishment order, like a production Kanban card. Nothing unique about that. But what was unique is within a few weeks, we reduced an $8 million inventory to $2 million inventory by putting in place those kind of controls. So this was a very, easy win, I guess you could say. So what is $6 million inventory reduction worth? Well, remember, inventory is not cost. It's not expense. It's an asset, supposedly. But there is a cost of carrying inventory, and it really depends on your industry what percentage you want to apply to that. But 10% or even more would not be unusual. So a $6 million reduction could result in, say, a $600,000 actual cost reduction that flows to your bottom line. Because it's inventory you don't have to pay for, you don't have to buy the material, you don't have to cycle count it, you don't have to store it, you don't have to throw it away when it gets damaged.
And it's a one-time injection of cash, right? Because that stuff goes and you don't have to respend it.
But you need to be careful when you talk about savings, because a lot of people who are maybe not as sophisticated might think, oh, $6 million flowed right to the bottom line. No, that's not the case when you talk about inventory.
Yeah.
All right. Next one, 5S, prior to hospital relocation.
This one, I'm going to make this one really short because one of our hospital clients had two old hospitals, and they bought a 62-acre plot in between the two, and we had the fortune of helping them design this new hospital. And that hospital has our thumbprint all over the place, including one of the few invasive centers where all the invasive procedures are co-located and patient prep and patient recovery is shared. I mean, it was a really a great privilege participating in that design. But one of the hospitals, both hospitals were very old, and there was junk all over the place. And one thing we noticed was, if the day of the move, all this stuff makes it to a new hospital, it's going to be expensive to move it, and we're going to be moving junk. So we had a big 5S project prior to that hospital relocation. And not only we threw away an enormous amount. I mean, it was dumpster after dumpster after dumpster of stuff that needed to be thrown away, but a lot of material that was donated to nursing schools, and that built a lot of goodwill, and that made the move a lot more efficient. And I remember discussing this with the facilities folks, saying, hey, the number of moving trucks that we had to cancel was also very significant. So if you are planning to move, doing 5S prior to relocation, big deal, saved a lot of money for these folks.
Yeah, and you probably developed another 23 lean aficionados in that hospital, right? People excited about lean because they got their hands dirty on that.
Oh yes. We trained them, certified them. Yes.
Okay, so let's go back to what we talked about in case one, We talked about check, do, check. And this is an example of that I liked. This was one I worked on. It was in Mexico. They were making rail cars. And interestingly enough, at a certain point of maturity in this line, the rail car gets put on rails, and actually gets pushed by a bunch of guys. I don't know if that would be legal in other places, but when they had to move the rail car to the next station, they just gathered a bunch of folks together and they would push it to the next station. Yeah, and I'll get back to the problem with that in a minute. But the idea here was this. As you can imagine, a lot of the work on these rail cars is welding. And so basically what they were doing was they'd weld it and push it to the next station and let it go through. And then at the very end, there'd be a welding inspector who would check it all out. And of course, there would be all kinds of things that needed to be fixed at the end. And we wanted to reduce or eliminate the need for that final inspection at the end. We wanted to build quality in or catch errors much sooner. And we wanted to make it very visual. So you may recall in case one, we talked about touch for quality. But how do you do that when you're welding a whole long seam? What are you looking for? Or how do I know what was inspected previously even? So what we did was we bought this. You've seen these big, thick pieces of chalk that kids use to do sidewalk art. You get out and do designs on a sidewalk. So we gave the folks on the floor these big pieces of chalk, red and blue. And the idea here was that you would as the unit came to you, you would look for chalk, unless you were station number one, you would look for chalk against the welding seams that were done previously, right? And you're going to do an inspection, but you're not just looking, you're taking your color of chalk and you're marking along with it. So if the original line was red, you have your blue or green color and you're marking that. And that records on that rail car that welding seam was inspected by the operators twice, right? The person that actually did the weld and the person that at the next station double checked it. Then the operator at that station is going to do their own welding, right? Different welding seams, complete that, and then inspect their own work and put their own color of chalk on that welding seam. So the unit, as you can imagine, as the unit goes through, it's going to be covered with chalk. Now that wasn't really a problem because further downstream, it was going to be sandblasted and painted, right? So we weren't really concerned about that. But that gave people a visual record that, hey, this was inspected by the person that did the weld because I can see the chalk mark there. Now, could they put a chalk mark without looking? Sure, but why would you do that? And then it was inspected at the next station. So this is just the check process, but with the chalk. But what was the end result? The end result was at the end of the line, I'm not going to tell you that they never found anything in final inspection, but massively reduced the workmanship that needed to be corrected at the end of the line. So reduced workmanship errors because they were caught earlier and fixed earlier if necessary, and not at the end, which was causing a real bottleneck in the past. Now, the other, sort of not related story that I wanted to share with you. These units are covered with chalk, and I came in during one of my visits, and one of these units had a big sign on it in chalk that said the flying rail car, el vagón volador, the flying rail car. I said, what the heck is that? Well, at the end of the line, the unit would go onto a carousel, right? It would go out of the factory onto a turntable, right? So they roll onto the turntable, and then they were able to turn it and then move it out of there. And during one of these moves, the team that was pushing the rail car by hand, remember, got a little too overly enthusiastic and got it rolling with a lot of nice momentum and realized the turntable wasn't there. At the end, it was off somewhere else, and the rail car went rolling right out of the factory and into the pit underneath. And so these workers took their chalk and wrote on it, the flying rail car. They had to get a crane, right, to pull it out and put it back on the tracks. So it had nothing to do with check to check, but I thought it was a funny story.
They didn't check the presence of the...
Right. Okay, last one. And just by way of introduction, this could be the biggest of any of the 10. similar to check to check. It's not that hard to do, but hardly anyone does this. And the kind of productivity impact you can have is just off the charts. So take it away, Troy.
Listen, I'm going to spend just a couple of seconds on this because, we have a 90-minute workshop on flexing in the Lean Science Studio. But not doing flexing is leaving money on the table. A well-designed mixed model line is not a fully staffed line. It must have holes in the line for people to be able to flex. Why? Because perfect balance is impossible. Now, could you refine and get closer? Yeah, sure, but perfect balance is impossible. So, not taking advantage of flexing, in other words, moving up and down the line based on demand signals, is just leaving money on the table. And we're talking about a minimum of 10% productivity, labor productivity, and up to 30% productivity. In other words, if you don't do flexing, you're wasting 30%, up to 30% labor. And we've seen it. We have absolutely seen this in places where due to labor union issues, flexing is not allowed. So that's all I'm going to say about it, because we are coming up to the end. Please learn about flexing. Come to our workshop in May to learn about flexing. And go to the Lean Science Studio. We have a 90-minute workshop about flexing. If you don't do it, you're leaving money on the table.
Well, you can see here in the middle picture, this is an AI-generated photo. I love it doesn't do very well at spelling normally, AI. It's getting better, but Visual Management System. But the intention here was to show a board with people's training or certification levels, because one of the things for flexing to be possible is that people have to be cross-trained. So minimum expectation in this kind of environment is you are certified or trained in a primary station, and then one to your left, one to your right, or one up, one down. That's not the maximum, that's a minimum expectation, and you need to keep track of this. So a management board like that lists your workers and lists the different skills that they need to have is visually displayed.
So, Richard, we're coming up to the end, and before we lose people, let's make sure that we invite them to our workshop.
Yes.
Folks, in a month or so, we have our Mixed Model Line Design workshop at Toyota. It is really a unique opportunity. We still have a few seats left. And not only you will see our workshop in which we teach mixed model line design, but also we are very fortunate that members of the management team at Toyota will do 2 tours and a Q&A session. We will provide breakfast and lunch, so come hungry. And we will have a happy hour on Wednesday evening. So we look forward to seeing you, and please go ahead and click on that link to come and sign up for the workshop.
Yeah, that link there will take you to an information page and an option to register if you can. But it tells you, in much more detail what takes place during those 3 days. But life-changing experience. Pretty much. And absolutely. Michael, thank you for posting the link there in the chat, so you can click on that if you want to go there directly. So highly recommended. I mean, the experience of those 3 days will stay with you the rest of your career and beyond.
Absolutely.